Good day. In this video, we're going to learn about what is electric current and the different types of current. Electric current is defined as the flow of electric charge carriers in an electric circuit. Electric current starts flowing in a circuit when there is flow of charge carriers, or you can say it as flow of charge carriers leads to flow of current. The charge carriers are usually electrons or holes. Electrons are negative charge particles and holes are positive charge particles. Flow of current can be due to flow of electrons or flow of holes. The electric current is represented by capital letter I or small letter I. The unit of electric current is ampere, or in simple you can say it as amps. 1 ampere of current represents 1 coulomb of electric charge moving past a specific point in 1 second. That is 6.24 times 10 to the power 18 number of charge carriers moving a specific point in a second is 1 ampere of current. Ampere is equal to coulomb over second. Direction of current flow. The direction of current flow is opposite to that of the direction of flow of charge particles. In this circuit, a battery is connected to a lamp through a resistor. The flow of electrons are indicated by this arrow mark and the flow of current is indicated by this arrow mark. That is, you can see that the flow of current is opposite to that of the direction of flow of electrons. The electrons are flowing in this direction and the current flow is opposite to that of the electron movement. Current in a series circuit. In the circuit, the three resistors are connected in series. So when the resistors are connected in series or when the electrical equipments are connected in series, the current across each resistor or the equipments remains the same. For example, if the total current across the circuit is 2 amps, the current across the resistor R1 will be 2 amps, the current across resistor R2 will be 2 amps, the current across resistor R3 will be also 2 amps. So the current across each resistor remains the same. Current in parallel circuit. In the circuit, the resistors are connected in parallel. When the resistors are connected in parallel or when the electrical equipments are connected in parallel, the current does not remain same. The current varies in each branches. Say for example, if the total current in this circuit is 5 amps, the current across the first branch may be 2 amps, the current across the second branch may be 2 amps, and the current across the third branch may be 1 amps. This branch current depends on the resistance offered by this resistors. So depending on the value of the resistor, the branch current will also vary. So if we add these three currents, if we add the branch currents I1, I2 and I3, you'll get the total current. So it is 2 amps plus 2 amps plus 1 amp, you'll get 5 amps. Types of current. There are two types of current: AC current, that is alternating current, and DC current, that is direct current. Alternating current. Alternating current is an electric current in which the flow of electric charge periodically reverses the direction. A good example is a sinusoidal waveform. An AC waveform can be sinusoidal, a square or sawtooth waveform, or it can be any shape. So in this waveform, you can see that the waveform changes from positive to negative quadrant in equal interval of time. So now it is in the positive quadrant, and after a particular period of time it is moving to the negative quadrant, and after that it is again moving to the positive quadrant. So it will be alternating, it will be oscillating between positive and the negative quadrant. So an example of sine wave alternating current is the household utility current or the current which is applied to most of the industries. Direct current. Direct current is the unidirectional flow or movement of electric charge carriers. This graph shows the flow of direct current. The intensity of the direct current can vary with time but the general direction of the movement always stays the same. So in this graph, you can see that a 6 amps current is flowing for a particular duration of time and there is no change in current. But in some cases, the current may be fluctuating in the positive quadrant or either it may be fluctuating in the negative quadrant. But it will never fluctuate between the positive and negative quadrant. The direct current will never fluctuate between positive and negative quadrant. The current rating. Current rating is defined as the maximum current an electrical appliances can carry continuously for a duration of time with complete safety. All the electrical equipments and components can withstand a particular amount of current which is mentioned in the equipment. So here is an example of a LG projector. This is the current rating which is mentioned in the LG projector. The current rating is DC 1.7 amps. This line indicates DC is a straight line which indicates DC. If it is AC, it will be indicated by a sine wave. If it is DC, it will be indicated by a straight line. So here it is mentioned as DC 1.7 amps. So the current rating of this LG projector is 1.7 amps. So if the current increases above 1.7 amps, the projector may get damaged. So it must be supplied within the rated current. So to keep the projector at the safer side, the resistors are used to resist the flow of current, which helps the current to be within the rated range. To measure the current, we'll be using a ammeter or either a multimeter. The current can be calculated using the following formula, that is I is equal to V over R. V stands for voltage and R stands for resistor, which is the Ohm's law. These are the brief outlines about current and the types of current. Thanks for watching this video. Thank you.